Hi everybody, Dmitry's here. So we got our calibration set up, and at this point we're ready to go ahead and start building our props. One useful thing though is, especially when using reality capture or professional version of Metashape, is to be able to set up custom ground control points using markers, and that would allow us to automatically set up all the scaling. To demonstrate the problem, let's look at this simple case. Let me take a screenshot of just this white background, and to demonstrate the issue, when we use photogrammetry and let's say we scan this little object and end up with, let's say, a couple of or multiple cameras of this sort that observe object from these angles, not very straight lines, but I hope you see the point here. So from the photogrammetry process, there's no difference between this scene and let's say the one that's scaled and this really large, and cameras are further, well, actually cameras could be as small as those other ones, but it would be the same geometry, but everything is pretty much scaled. So when we run photogrammetry out of the box, there is no difference between these two scenes. Essentially this is all exact. And now when we're dealing with photometric process and we have all these lights defined at very particular position around all these cameras, we cannot really use like for instance on this one on the left, if we don't work with proper world units that are related to world size units, we're not gonna get proper results. So we'll get things that might be completely wrong. So that's why in our photometric process it's important that all the source data is in known world space units. And one way to ensure that is to use ground control points. And now let's go ahead, and we have our color checker scene already, not the scene, but all the images already transformed and set up. And what you see here is the bottom. We tried to shoot a lot of objects, at least the first loop, with this predefined prop. It could be like a box or but something that has straight faces as well, and some pseudo-random textures, as you can see, and it would have these relatively small but still distinguishable markers placed there. You don't want to use too small markers, and you don't want to use too large markers. Like in this case we use 5 per face, and the reason is that sometimes these ones at the bottom get caught by your framing, like in this case almost, or when we look at our octopus prop, then you'd have some part of the object, like for instance like in here, partially occluding some of the markers. So we kind of want to have good visibility so that they're visible from as many different views as possible. And one cool thing, now let's go ahead and open our reality capture again, and one cool thing here, if we add these photos, is that we can predefine all those positions, and the next time when we process this prop we could run that and it would automatically orient and scale everything properly, so we don't need to go and measure something manually, though sometimes we still have to do that when there's no way to place those markers. Sometimes we would do some very like edge case macro photography where there's just no place for the marker there. Anyway, if we click to alignment and detect markers, here we have marker generator, and one important thing is that when we select marker type, these are predefined families of markers. Currently in our photometric framework for other types of automation, we only support two of them. One is square 16H5 and 36H11, and that's what I showed you in the overview. You can either, in this case I know that it's 16H5 and it only has 30 markers there in that family, but then we can go and generate. Here it says marker limit, so we would go and switch it to 30 per page. Okay, generate, and it will basically generate us a PDF file that we can print, but it would be in whatever arbitrary size, and we have, if we go to reciprocal scans, scripts, build, mesh tools, to the square April tag 8mm, we already have something that's nicely placed here, and if you zoom in you can see these dots that are useful for for when you are cutting it. One important thing with these markers is that you need to have this white edge around this black square. That's super important, so don't cut it like super close to that edge. Anyway, going back, so in this case, once we have all those markers printed and placed here, like here on the image at the bottom, you can see that that edge is super important. We can go ahead and click detect, and now reality capture went ahead and detected all these markers. Now they have names, and we can see that some of them are visible from various more than a single image. We know if it's 5 markers per phase and 4 phases, so we should have 20 control points defined. We definitely see this one that only is visible from one image, and we have 21, and if we zoom in, it's obviously a mismatch, like an outlier, so we should just go and delete it. That's not a valid point. So at this point we have 20 of our points, but they currently exist in whatever space, not respecting real world units. Now we need to set up a custom constraint for the distance to make sure that everything is to scale. One way is to either go in real world and measure some distance between these two, but I'm gonna show you another way where, because we already have our color chart in here with a ruler, let's just use this ruler as a reference for our scale. So if we go to add control points, let's click over here, let's call this point A, and now let's click at this one at the bottom. That's going to be our point B, but we will need more than one image reference for those. So let's click on the next image here. So that was image 12. Let's go click on image 1 and do the same stuff here. Click over here. It says it's point 22, but it should be point A. So let's grab this one and drag it into A, and the same we'll do at the bottom. Click here. It's point 22. Let's drag it into B. So at this point we have our 2 images defined, and that's enough to do all the distance calculations there. To be a bit more accurate, let's go ahead and do similar stuff for one more image. Also click at point 22. It's going to be point A, and this one is going to be point B. Drop it in there. So there you go. We have our 3 images. That's good enough for distance estimation. So now click here, create distance, and it's going to create a distance constraint, and point 8 is going to be A, and point B is going to be B. And It's not enough points defined. Why is that? I think it should work right now. Do we need to call up update? There is no update available. And that is yes, so the reason why is that we didn't do alignment process. So let's run the alignment. Yes, let's make sure we have a single component there, and all the cameras are good. Yeah, that's all good. Now we have all these points defined in a 3D scene, and we also have our distance there. You can see between A and B. And now if we click at this distance, we can see that calculated distance is 11.44 something, whatever units, we don't know it, but we know that in real life it's 5 centimeters. So in meters it's going to be 0.05, or one way to think about it, 0.050 millimeters there. So we click OK, and at this point we have to click update, so that everything would get scaled according to these constraints. So there you go. So at this point we define this distance, and now after all this extra consideration, it's decided that calculated distance, the actual one that it thinks it is 0.0499953. So for us it's more than enough resolution and accuracy there, so we say that it's okay. And here it says 0.0 meters, but it doesn't show you the that's just the display issue. So at this point we have the whole model in the same scale. Let's make sure that also we go to tools and set reconstruction region, so everything is set up nicely here, and we can rotate around it. Let's save this scene. Before we move any further, let's call it chart ground control. Okay, so one thing right now is that even though we have our scale set up, ideally what we want to do, we want to move this object around such that these faces are nicely aligned with the one that we have in the scene, and so it would look like as if when the object is reconstructed, as if it stands perfectly on this grid plane. So in that way we'll perfectly have not only scaled the model but also aligned it nicely, where front face is the front, back is the back, and so on and so forth. To do that, it's a bit hard to do it with just points like this visible, but let's do a regional kind of rough alignment there. Let's go to set ground plane. So at this point we have our gizmo that we can use to rotate and move this whole thing around, so we can do things like that. And now it's useful to go to the top view and have everything. So the front, in this view, the front is going to be from the top of the screen. So when we see this A and B, that's basically us looking like from the top there. And just on these markers, they're placed more or less symmetrically, so it's a good first guess to just align them based on that. And it doesn't have to be perfect, but it helps when it's aligned nicely. Let's go to the left view, and we don't see, well, to the right maybe. Yeah, let's move it. So at this in this view, just using this point, it's quite hard to tell where the box ends and our color chart begins. So we'll have to So we will have to build a mesh so we can set that whole thing a bit better. But this is our front view. In general, that looks about right, similar to what we would have on those images. So yes, let's go ahead and build our, I think, preview. Yeah, preview is not very useful. Let's do normal detail model. So this way we will be able to tell where that top face of the of this box is, so we can try to align it a bit better to that ground plane. There you go. We got our model reconstructed. Let's see what it looks like in perspective. Reset view. Oh, that's let's double click like that, and right now it would be, I think we'll have to, as you can see, reality capture doesn't quite cooperate here. So as we move around, our grid also kind of moves up and down, which is probably some type of rendering issue. So that definitely not what it's supposed to do, but we can see that our box is a bit misaligned there. So let's go ahead and try to do a better alignment, maybe from this perspective. Basically, we try to make it so that as if that color chart stands on the ground. What does it look like from the front? So you can see it's a little bit crooked here. Let's maybe like that. I'm trying to move it up to align it with the face, with the top of the window there. So from the right, probably it's good. Let's verify it from perspective view again. I would say it's probably, yeah, it's probably good enough. Let's also look at it from the top. Go to vertices, switch to the top view, make sure that faces are also aligned here. Looks good, I think. Let's go ahead and, because it looks a bit messy, let's remove those models and look one more time at these marker positions. So I think everything looks pretty good here. So we can see everything good looking from the front, from the top, in perspective, everything is good. So at this point we can uncheck that set ground, save the file, and the next important step here is to control all these points. And as you can see, when we click on them, it's going to say here type point, and we would now have to manually go and convert each and every point in this list into a ground control point. And to do that, you click on the first one, you change type by clicking here to ground control, and you would see that here coordinate system is not defined, the actual one is also not defined, but we now need to go ahead and copy these coordinates one by one like that into these fields at the top, and also change the coordinate system to local 1 Euclidean. And now it's gonna tell us that coordinate system is not defined, set up with blah blah blah. We click set to the project. So now we see that both of these are going to be local 1 Euclidean. We'll make sure that these coordinates are the same. An important thing over here in this window on the left is that now next to this marker we have this georeferenced icon over there. So at this point it's going to be super boring, so I'm going to speed up the video. But you'll see me going through each and every single one of them and doing the same stuff. So for you that should happen very quickly, but I'm gonna go ahead and do all those things. So there you go. I've just went through all these 22 control points, and we converted them to georeference ground controls. Let's now save our scene. I would also go quickly through them again to make sure that these coordinates here at the bottom and at the top match, just to make sure I did not make any mistake there. And everything looks the same so far. So there you go. So everything is great, and at this point, under alignment tab, we're ready to go ahead and click export ground control, export GCPs. And if we click there, let's go ahead to our scans and props directory and call it something like main box GC, standing for ground control. And the format here by default, comma separated name XY, altitude, which is Z, and I would have to use the same format when importing them back. So let's go ahead and save. Here the most important thing, make sure that coordinate system is set to grid plane here and nothing else, because that will make sure that everything is corrected to what we saw there on screen. All these other settings should be like here by default. In case if you have different values, make sure it's all move and rotate zeros and scale 1, and normal transformation we don't care about. So let's go ahead and click OK to make sure that everything looks good there. Let's go back to this file. So now we place it next to our rig definition file. So if we open it, we could see that essentially for every point there we have its world space coordinates. So that whole thing defines our whole frame of reference. And the cool thing about it is that in practice we only need at least 3 different points out of this list to have something set up and be accurate. So the more points we have, the better. And at this point, all that looks good. All that stuff is saved. So we saved that. Now let's make sure that if we go and export registration, just in this scene, internal and external camera parameters, in our chart we have this RC_cameras folder. Let's go ahead and override that. That's an empty file by default. And this is our general way to export all the camera registration from reality capture, making sure that in internal external camera parameters in CSV format and coordinate system set to grid plane, and everything else is set to by whatever values you have by default there. So now all that is exported, and then we run the RC cameras CSV to cameras XML script, and that's our main script for converting to the format that our system can understand, and it's very similar to what Metashape uses. So technically you can go ahead and even import this file directly into Metashape if you want your cameras in there. But the reason I'm doing this right now is to make sure that all our scale is good. In our framework internally, all the values that you see, we use millimeters, and right now we set up everything in Reality Capture to use meters. So technically this camera registration file that we exported, if we go and check against our custom marker pipeline, we should have roughly the scale close to 1,000 there, meaning that in Reality Capture right now it's in meters. So 1 millimeter is 0.001, and in our case it's just 1. So for that, for our pipeline, we have the script called marker info, and if we run it, it's gonna give you an error telling basically that you need to make sure you have markers there and the size of each marker is specified. So as I said before, we support 2 families at the moment, 16H5 and 36H11. 16H5 only has 30 markers, but they're more robust under like out of focus conditions and occlusion conditions. 36H11 has around 600 markers. They're a little bit more dense, but there are a lot more of them, so you can use them for a lot of other things as well. So if we open this script in the editor, marker size in millimeters, this is what we need to now go after we printed them and measure what that size is in real life. And here I have an example. So even though I printed that file with 8mm scale in printer settings, it did rescale something. So I ended up with, instead of 8mm, with 7.9mm, as you can see here. You need to measure this actual distance of this black region. So 7.9, that's the value that we will be using. So in here we just need to punch 7.9, and if this is something that you use all the time, technically you can go to this basically prop template photogrammetry and modify that distance, punch it in here, so next time when you work on the next prop you wouldn't need to do it again. So essentially you can create your own presets that way. In this case, if we go back and run this marker info stuff, it will go ahead and read everything in there and does the analysis. And in this case, we don't rely on that ground control stuff, but just on the marker stuff, marker sizes. Here, assuming it's a Sony camera, did all the estimates there. It estimated that the scale is 966, which is pretty close to 1,000. So if we divide 1,000 by 966, we get about like within 3% distance difference there. That's pretty good. And if you're really sure that all that ground control stuff is very accurate, you can just override that to 1,000. Important thing here, it also estimated the distance to the plane where exposure was estimated. Exposure compensation value in this case is 1.56. We do photograph everything a bit underexposed and then relying on log spaces to recover some of that shadow information and midtones when saving to JPEG. The reason for that underexposure is so that we have as little clipping of highlights as possible. And in this case we can see that it's also updated this default parameter settings with these ones estimated. So at this point I just ran it just to make sure that all our ground control points are where they should be. We can go under solve param settings and make sure that yes indeed this is our scale. If we're really sure that we always use these ground controls and they're accurate, we can just set it to 1,000 in this case, and that would be it for all our that would be the value for all our props that we build, and that's our exposure compensation. And that exposure compensation is essentially defined at this distance from the camera, which is 50 centimeters, essentially 505 millimeters. That's the distance at which the color chart, if it was built at that distance, would have all the proper values. And when this marker pipeline is not defined, you can still go ahead and build all the stuff, but you would have to figure out those values manually. And we have tutorials on how to deal with all that cross-polarized footage and color chart, how to derive these values manually. So at this point we finished this ground control, and in the next sets of videos we'll actually go ahead and build actual props and materials and see what that whole thing looks like from the user's perspective. I'll see you there.